Hello, I'm Dr. Harper. This video is in Operations Management BANA 3000, Section E02, Spring 2021, and this is the exam study guide. I've posted the exam study guide in Canvas, and this video will go over the details. So let's bring up the exam study guide. Okay, it's a study and review guide. The exam will be online, multiple choice, timed, open book, open notes. Exam will be over 6 course topics, 30 multiple choice questions, 1 point per question. It's 90 minutes. There's no collaboration and no internet is allowed. Everyone needs to required to do it themselves. Okay, summary. Exam will be online, multiple choice, timed, open book, open notes. No collaboration, no internet. Each student must take their own exam. Again, it's over all 6 topics. Approximately 4 to 5 questions a topic. Sometimes there's a combination. 30 multiple choice questions, 1 point per question, and you have 90 minutes to take the exam. No exam is accepted after the end of the course. And if you don't take the exam, well, then you get a 0 for the exam, and that will be counted in. The exam is designed for evaluation. I'll show you what I mean, because I'll go through a sample exam. Okay, exam information from the syllabus, and I copied this right straight from the syllabus to make sure everyone is fully aware of the syllabus information. So I stated again here that you must take your own exam. No collaboration is allowed, and for the exam, you may use your notes, the book, anything you have, just no other person, and you can use a calculator. And you'll need a calculator for adding here and there, but nothing, but no internet. No exam taken will result in a 0 for the exam, and no exam will be considered after the end of the course. Now, the design here is approximately distributed among 6 topics. 5 questions on the definition and quality control, 5 questions on forecasting, 5 on aggregate planning, 5 on inventory, 5 on MRP, 5 on scheduling. So it's approximately 5 questions per topic. Okay, but in order for the evaluation to prepare for the exam, what I'm going to do in this video is go through a sample exam and tell you the types of questions they're going to be asking, the material to cover, how to study for it, and to how to prepare. The sample questions and answers presented in this sample exam represent examples. Wording and the values in the actual exam questions and answers can vary from this sample exam. But the exam questions will be based on the material represented in these sample questions. In other words, I might have the wording differently, I have different numbers, but the material will be on that type of question. The sample exam presented in this study guide is merely for instructional purposes. The correct answer for each question in this sample exam is option A. So it's easy to go through and say, that's the answer, here's other answers to compare, to see how to go about it. Which will not necessarily be the case in the actual exam. Hopefully that's apparent, but I'll state it up front. So let's go through the exam. Let's go through the sample exam. Okay, topic 1, questions 1 through 5, definitions and quality control. And this is that first lecture. For instructional purposes, in this sample exam, the correct answer for each question is option A, which will not be the case in the actual exam. I state this on every topic. Okay, sample question 1. Which was presented as a type of industry where the customer is part of the operations? Well, it's going to be a service industry. Now, remember, there was a batch industry, a repetitive industry, a job shop industry. There's all different kinds of industries. But this is talking about the industry, the general industry, continuous versus intermittent, that type of thing. But then customer as product is which type of design and operation strategy. So this is a design within a strategy. Okay, well, customer as product was a service process design. So remember, we had the product design, the process design, the inventory design. So I could have questions on all 3 of those. So get that lecture up and get ready to have a question on those types of designs. Question 3, the combination of product focused and process focused is found in which type of operation strategy design? It's going to be process design. As a matter of fact, it was referred to as cellular manufacturing. So, and also the product, we combine those. The inventory, there was a push-pull, a push and a pull, and a push-pull was in the inventory. So those are the kind of things come prepared to answer. Question 4. A strategic function leading to a strategic decision usually applies to what type of term? What's long term? Remember, medium term was more planning, short term was day-to-day operations. A simple statistical process control chart is constructed using a mean of 5, standard deviation of 1, sample size of 9. What is the upper control limit for the chart? Now, this is the exact question and the wording that I will use for this question number 5, or the 5th question. But the numbers will be different. And notice what the answers are. I don't give the actual number, I give the equation. So be aware and understand what the equation is. Okay? And here it's 5 plus 3 times the standard deviation divided by the square root of the sample size. Okay. So just know that equation. Okay, topic 2 is forecasting. Okay, and some of these will be the exact questions for the exam. Some of them are very similar, just the numbers are changed. For example, for a time series 486 for weeks 1, 2, 3 respectively, what is the forecast for week 4 using an MA2? And so that's exactly the kind of question I will ask, but I'll have different numbers here. I'll have maybe MA2, maybe MA3, but MA2, you average the last 2 numbers. 6 and 8 is going to be 7. If the seasonal index is 2 and the seasonally adjusted value is 10, then what is the seasonal value? Well, if the seasonally adjusted is 10, you want to put seasonality into it, you multiply by the index. And so there's 3 things here: the seasonal index, the seasonal value, and the seasonally adjusted value. I'll give you 2 and ask for the 3rd, so I'll mix it up. So just have that equation in front of you. Sample 8, question 8. Consider the 3-year forecast for the quarterly time series assuming only a seasonal and random components. So for questions 8 and 9, I will give you a table just like this, and I will ask for the seasonal quarterly forecast, and then what's the seasonally adjusted quarterly forecast. And so the seasonal forecast for, say, quarter 1, well, this is the sum, and I'll give you the sum. So I'll be giving you the sum. So the sum here, since it's a sum of 2 values, it's just going to be 240 divided by 2. If it's quarter 3, it's 330 divided by 2. Now down here for the seasonally adjusted, it's the average of all 8 numbers. Well, you have this sum over here. So it's 1200 divided by 8 right here. And so that's the arithmetic you use on each of those questions, because it's just to evaluate and to verify that you understand what you're doing with those numbers. Now, question 10. Consider the 3-year forecast for the quarterly time series using only seasonal random components. Which quarter has the smallest seasonal index? Well, it's the one with the smallest sum. Okay, well, it's going to be quarter 1 here. I could say the largest. Well, that's going to be 360 because that's the largest, quarter 4. So question 10 will be just like that. Okay. 11 through 15. Well, for aggregate planning, what is the output of aggregate planning? It's the production plan. And so for this one, I want to emphasize this question and answer. So I'll ask this question. That's the question. That's the answer. I just put the answer either A, B, C. It'll be all over the place. But that I just wanted to verify, just to emphasize that the output of aggregate plan is a production plan. Which aggregate planning strategy does not have the most control over inventory or the most control over labor FTEs? Well, that's going to be the mixed plan, because Chase has the most control over the inventory. level has the most control over the labor. Okay, so therefore, now I can ask this in a lot of different ways. So just be aware of that concept, to where all the variability in the demand will be reflected in the FTEs for chase in the inventory for level. Level will stabilize the FTEs. Chase will stabilize the inventory because there's no variability in there. Okay, because you have control of it. So I'll ask this. This is a concept, a takeaway from aggregate planning, which I think is important. That's why it's going to be on the exam. Okay, now we get into some assuming a level strategy. The beginning and ending annual inventory is 9. Assume a carrying cost of $1 per item per quarter. What is the production for quarter 3? So I give you a lot of information up here. Notice the production for quarter 3. All you need is to know that it's a level strategy, because then you take the sum and divide that by 4. That's what I'm doing here. If it's a chase demand for quarter 3, it's just going to be 36. And so that's all you need to know. You don't need to know the beginning and ending inventory, or the values actually. Could be anything. Again, a level strategy. I say for a level capacity strategy, beginning ending inventory 9, carrying cost of $1 per item per quarter. What is the total carrying cost for quarter 2? Okay, this is the one where you have to actually do some computation and actually some thinking. Well, you have the ending inventory here for quarter 1 and quarter 2. Well, you want the total carrying cost for quarter 2. Well, the ending inventory for quarter 1 is the beginning inventory for quarter 2. So if it begins with 13 and ends with 11, what's the average inventory for quarter 2? Well, the average between 11 and 13 is 12. Well, if it's 12, then what is the carrying cost for quarter 2? Well, it's $1 per item per quarter, so it's 1 times 12. So I make the numbers simple. You just have to know how to put them together. And so again, I will ask this question, okay? And it will be, what's the average, the total carrying cost for quarter 2, quarter 3, quarter 4, whatever, okay? And then assume a chase demand. Now, question number 15, the 15th question in this exam will be exactly this. If it's chase demand, I could ask different things. Then I give you the demand here. What is the ending inventory for quarter 2? Well, if it's a pure chase demand, it's just going to be 9, because the inventory doesn't change. What's the total annual carrying cost? Well, if you have 9 all year long, the average inventory is 9. If it's 1 per quarter, then it's 4 per year. 1 times 4, 4 quarters in a year. 4 times 9 is 36. What's the production for quarter 1? It's just going to be the demand. So for chase demand, it's just knowing the properties of chase demand when you're given the demand and given these values up here. Okay, now for inventory. So now for inventory, this first question here, I'll ask a question just like this. It'll even be worded just like this, but the numbers are different. Well, the safety stock is going to be 0, but I'll put a different number there and a different number there. So the idea here is, remember the graph, the break-even graph in EOQ. Well, if the lot size Q is at EOQ, then the ordering cost equals the carrying cost for a safety stock of 0. So the idea there is that if the lot size, if Q is greater than EOQ, then you're ordering more than you need. So which one of those costs is greater? If you're ordering more than you need, the carrying cost will be greater. If EOQ is 50 and Q is less than 50, if you're ordering less than what you need, then the carrying cost will be less than the ordering cost. And so again, in inventory, this is a takeaway that's important. And so I have it there, question 16. Now question 17 is just recognition. For an inventory period of T, reorder point of ROP, a lot size of Q, lead time of LT, safety stock is this. What is the inventory policy for a continuous review system? Well, continuous is ROPQ, periodic is TQ. Okay, but what I'll do is I'll actually put numbers in here. So you have to pick the right numbers down here. Okay, these are two numbers where the first number is ROP, second number is Q. This is a time where the first time is the inventory period and the second number is Q. Okay, then we do some computations. And here's where you will need a calculator and a square root for question 18. I'll give you the demand, ordering and carrying cost, item cost, lead time, safety stock, and I'll put it exactly like this. I'll say, what is EOQ? So it's a square root of 2, and actually I'll make, and notice what I have here. The demand is in years, the carrying cost is in months, and so you have to transform the months to years, and so it's 2 times your demand per year times your ordering cost divided by your carrying cost, which is 6 per month, but I have to multiply by 12 to transform the month to a year. So here is the actual computation within inventory that you'll be using, one of two. The second computation is going to be the same type of information and what is ROP. That's demand times lead time plus safety stock. Well, notice the demand is in years, the lead time is in weeks. And so here I would suggest transforming the demand to weeks. So I take the 520, divide by 52 weeks in a year to get my demand per week, times the lead time, plus my safety stock is 18. So you will need to have you will need a calculator for EOQ and for ROP. Now, sample question number 20. Again, I give this information, and then I say, what is the total annual carrying cost for an annual order frequency of 52? So question number 20, I give you EOQ, ROP, you plug and crank to do the arithmetic. But for sample 20, you have to do more than one step. You have to do a couple of steps, okay, to make sure that people know how to put these things together. Okay, the annual carrying cost for an order frequency. Well, remember Q equals D over F. You need to get the lot size. So you take D over F, that's the lot size Q, over 2 is the average inventory. Okay, safety stock is 0, times your carrying cost per year. Well, the carrying cost per quarter is 6, so 4 times 6 is my carrying cost per year. So there is some putting a number of things together. One, going from frequency to lot size, going from lot size to average inventory, and then multiplying times your carrying cost per year. It's going from carrying cost per quarter to carrying cost per year. So there's a number of things here. So this one, notice in inventory, I start with what is EOQ? Just putting the numbers in the equation. ROP, putting the numbers in the equation. Here, you have a number of equations that are put together. Okay. Now MRP. Now MRP here, if an order is released in the past, received before the present date, then what type of receipt is it? It's a past receipt. And so this question will have an order released and an order received. If it's released in the past, received in the past, it's a past receipt. If it's ordered in the past, received in the future, it's a scheduled receipt. If it's ordered in the future and received in the future, it's a planned receipt. So those are the definitions I'm asking in this question. Question 22. For a time period, now what I mean by this is any time period within an MRP, the values, the net requirements of 9 and the lot size discipline fixed at 2 will generate a lot size of what? Which lot size? So the idea here, I'll always have 2. I'll always have fixed at 2. But this net requirements will change. Like if it's 7, well, 2, 4, 6, 8, it's just one more than 7, which is 8. If this is 15, 2, 4, 6, 8, 10, 12, 14, 16, it has to be 16. And so it's going to be one more than whatever this is. But also in the exam, I'll give you more information here. You don't need any of that information. All you need is those two numbers. And so this question, I'll be giving you information. You have to look for the net requirements. And for the net requirements, you don't need any of that other information. In the lot size discipline, those two numbers are all you need to determine the lot size. And so I'm emphasizing, first of all, how to determine the lot size of those two numbers. But also I'm emphasizing that to get the lot size, those are the only two numbers you need in MRP. Okay. So number 23, complete the July 1st end item MRP. Well, when you do this, be careful. Look at the question. What is the planned order release for July 2nd? So all I care about is that cell right there. That's all I want. You don't have to generate the whole thing. Okay, and what I mean by complete to July 1st, begin completing it and then find the answer. For example, this is 76. So that'll be for the lead time is 1. So what's the lot size in July 3rd? We have 66 plus 20 is 86. Minus 76 is 10. Well, my lot size discipline is fixed at 12. I come back 1 week and I order 12. Okay? And so that's the mechanics you do. And by the way, I will give you this information, and I give you, well, sometimes I give you this information, sometimes I don't. But if I do, all you have to do is 30 plus 48 minus 2 equals that. And then 66 plus 20 minus 76 is the net requirements. Then from that, you compare that to lot size discipline. So that's the mechanics. Okay, number 24. Again, complete the July 1st, but I'm going to give you all the information up until July 5th. What is the projected stock balance for July 5th? So all I want is that cell. Well, on this one, the lead time is 1. I already have my planned order release there. So 36 plus the inventory on hand, which is 24. 36 plus 24 is 60. Okay, minus 33 then will be 27. Okay, because 27, 33 is 60. So it's just some arithmetic. It's just adding two numbers and subtracting a number. You just have to know which numbers to add and subtract. Okay. Now this last one, I always ask this because I want to emphasize, and this just test, does anyone know, just to make sure and test that people understand what schedule receipts means. In other words, lead time is 1, so therefore schedule receipt only has value in the first time period in the MRP. I say, what are the schedule receipts for July 4th? Well, for July 3rd on, it's going to be 0. So that's always the answer for this question, because I'm always asking for July something. If the lead time is 1, I'm always asking 2 and greater than that lead time into the future. So the schedule receipts are always 0. Okay. Okay, now scheduling. In a queuing system, if a job has a queue time of 1, a processing time of 2, then what is the flow time? Well, it's 1 plus 2 is 3. But for the exam, the flow time equals the queue time plus processing time. There's 3 things there. I'll give you 2 and ask for the third. So I could say if the flow time is 3 and the queue time is 1, what's the processing time? 2. If the flow time is 3 and the processing time is 1, what's the queue time? 2. So that's the idea. Okay. Now 27, consider the jobs processed on one machine where the schedule of jobs A, B, C, D is in the order 1, 2, 3, 4, or first, second, third, fourth. If the processing times for the jobs in the schedule A, B, C, D are 1, 2, 3, 4, then what is the flow time of the schedule A, B, C, D? Okay, now, if you remember, it's cumulative. It's a cumulative processing time. Well, this is the first job. That's the second job, third and fourth. Well, the fourth will be added only once because it's the last time. The third job will be added twice. The second job will be added 3 times, and the fourth job will be added 4 times. So this is 4. 2 times 3 is 6. 6 times 4 is well, here it is. Here's 4. 6 plus 4 is 10. Plus 6 is 16. Plus 4 is 20. So you'll be adding this thing. As a matter of fact, I think I have 3. I only have 3 numbers in there. You just know how to add them up to get the flow. Because the flow is such an important diagnostic, I think these mechanics I think are important. Okay, which was not presented as a sequencing rule in a queuing system? Well, the sequencing rule, or MPT, earliest due date, minimum start date, minimum slack time, minimum critical ratio, and Johnson's rule. Those were the 6 sequencing rules that I introduced, along with FIFO and LIFO. And so the process control chart decision rule, that's not a sequencing rule. However, on this question, what I will do, I will also, instead of just saying not a sequencing rule, I'll say which sequencing rule minimizes flow in an n/1 system? Which sequencing rule minimizes total processing time in an n/2 system? Well, the answer to this is MPT. The answer to this is Johnson's rule. So those 2 questions will be part of question 28. Depending on your exam, I mix them up, your exam will probably have one of those. Question 29. Consider the 2 jobs, the processing time on 2 machines where the times are in hours. What is the Johnson's rule schedule? I always ask this, and I try to make this as straightforward as possible. Notice the numbers you have in this table. And I try to make, here's 1, 2, 3, 4, 5, 6, 7, 8. Okay, and so you could just look at the first numbers. Well, the lowest number is 1. Well, 1 here is on machine 1, it's on job C, so C is at the beginning. Well, there's a C, there's a C, there's a D, there's an A, so it's either A or B. Okay, and then what's next? 1, 2, 3 is right here. So A has a 3 on machine 2, it's at the end. So that's D, that's A at the end, so the answer is CBDA. Because it's the only one with a C at the beginning and A at the end. Now I mix them up a little bit, but I'll try to make these numbers 1, 2, 3, 4, 5, 6, 7, 8 kind of thing. And that's how you do it. Question number 30. Consider jobs processed on 2 machines where time is in hours. I give you these numbers. And I will ask you one of these 3 questions. What is the processing time of job A in the schedule ABCD in the order 1st, 2nd, 3rd, 4th? Well, the processing time, you just add those 2 numbers together. That's all you do, which is 782. What's the queue time of job A in the schedule ABCD? Well, the queue time of the first job in any schedule is always 0. Know that property. What is the flow time of job A in the schedule ABCD? Well, the flow time equals the queue time plus the processing time, but the queue time is 0. So the flow time is just the processing time. Just add those 2 numbers together, 782. So I'll ask you one of these questions. So it sounds like, oh, let's see, processing, oh, well, the numbers are right there. And by the way, in the exam, I don't use 3-digit numbers. I use 1 or 2-digit numbers. Much smaller, easier to add in your head. You'll see the answer. And so again, it's for evaluation that you do know how to do this. So I try to minimize the arithmetic. There's a few places in here where you have to do computations and square roots and multiplying and dividing and adding. But other than that, these are the kinds of questions I'll be asking. And in many cases, these are the exact questions I'm asking. It's just different numbers. Okay, or I might change the wording a little bit. So if you have this in front of you, and I have the exam study guide posted in Canvas, when you have that in front of you, then prepare, and then the exam should not be should be straightforward, and you should do fine. At least that's what I'm hoping, and that's why I'm giving you this exam study guide. So that's all I have for this exam study guide. The only thing we have left in this course now is exam and the project. I'll have a video on the project, and then we're done with this course, and I hope this helps. Between now and the next time I see you, I want to urge everyone